Hello guys, this is the fourth video for 7522, and if you're watching this video, I would assume that you've watched the previous one, so I would skip some parts that I would believe you understand. Okay, now 4 engineers are to be allocated to 3. First of all, let's start like this. 4 engineers are to be allocated to 3 establishments, okay, by the federal government. How can this allocation be done? To maximize their utility using the deterministic dynamic program, okay? And the table below hints. Now we have 4 engineers, so our constraint is 4 engineers. And remember from the previous video I told you that our constraint is S. So hint, perform S for socks, S2 is 4, S is 4 generally, as to be allocated to 3 establishments. The same way we had countries the other time, that's the same way our X will now be 3, our S will now be 4, okay? And the objective aim is to maximize their utility. Alright, so the hint is there, sure, but the data is here, okay? So solution, remember the other time, once we start with when n is equal to 3, he said it won't give us anything above 3, so let's say once the country, you start with the third one, okay? So you just copy this table, this will be S, write this as F3S3 maximum, okay, automatically. And then you know the same way we do it now, you trace where this value occurs, at whatever you see here, write this, okay? I will assume you understood the other video, okay? So you just copy the same thing here, copy the same thing here, exactly the same headings, and then whatever values you have here, you write them as F3S3. I hope you understand. Alright, so then you move to for N2, that's for country 2. This is the formula. So the same way we did the other one, when we varied we varied S2, we're providing country 2 with 1 originally, so S2 is 1 for country 2. So the formula becomes this, at S2 is 1, and then you start varying your X2. We're trying to find how many they will optimally need, okay? So we're trying to measure the performance at, if they optimally need 0, obviously the performance will be 20. If they optimally need 1, the performance will be 50. Once you get to minus, you stop. Alright, so let me move to, you do for S is equal to 1, 2, 0, 1, 2, 3, 4, 4. You stop at 4 because here our S is 1 to 4. You cannot exceed 4. Okay, the other video our S was 5, that's why we did up to 5. Okay, so let me do for S is equal to 4. So the formula becomes this, for S2 is equal to 4, you substitute 4 here. Now we start varying at X2. For X2 is equal to 0, it becomes this, then you substitute it as this. Okay, so then wherever you see, look at now, I'm so looking for the performance of 0. I'm looking for performance of 0 medical teams in country 2. Performance of 0 medical teams in country 2 is 0, so you substitute here 0. Performance of 4 medical teams in country 3. Performance of 4 medical teams, 4 engineers in country 3 is 75, and you substitute it here, then 75. Then once you do that, you do for 0 to 4, and then for, if you allocate, we're trying to find out how many they optimally need. Now if they optimally need 4, that means X2 will be 4, and you substitute it here, and then we're looking for the performance of 4 engineers in country 2. Now performance of 4 engineers in country 2 becomes 90, substitute here. Performance of 0 engineers in country 3. Now 0 engineers in country 3, substitute, sorry, 0 engineers in country 3 is 0, so you substitute here. So when you're done with that, you draw your table 3. Sorry, this should be table 2, not table. Okay, let me check. Should be okay, yeah, table 3. Now you draw it exactly the same way. The first column will be S2, then you write your formula here. We're varying X2 from 0 to 4. And then for F2, remember I said once you find anything asterisk, you look for the highest value from 0 to 4. Now optimally, obviously, if you say something is performing optimally, that means it gives you the highest reasonable and profitable value. So you look for F2, S2 asterisk, occurs. Okay, now this on this row 0 is the maximum value, on this row 20 is the maximum value, on this row 50 and 40 is the maximum value, on this row 70 is the maximum value, and on this row 90 is the maximum value. Now where does this maximum value occur? It occurs at x is equals to 0, and it occurs at x2 is equals to 0. This one occurs at x2 is equals to 0. This 70 occurs at x2 is equals to 3. Now 90 occurs in two places, 3 or 4, so we write it here. Okay. Now, so the same way we did the last one, we move to country 1. Now automatically our country 1 will be allocated 4. I explained this in the previous video. So the formula becomes this, and then you vary from x1 is equal to 0 to x1 is equal to 4, and then you do the same thing you did in the previous videos. Now you draw your last table like this, and then you put in your values on the table into this like that, 90, 80, 75, and you look for the maximum value. Maximum value is 90. There's something missing here. Our s1 is supposed to be 4. There's supposed to be 4 here. Now the decision is, so x1 is equal to 0. The reason why x1 is equal to 0 is that the maximum value occurs at x1 is equal to 0. That means they don't need any engineers. They are performing optimally without any engineers. So there's no point wasting them. So x1 is equal to 0, so that whatever is now left available for the second organization or something, for the second country, I don't know what's it, for the second establishment is S2. If country 1, there are 4. If first establishment is not taking anything, that means automatically for the second one there are 4 remaining. Alright, so you write this, and then if you go back to table 2, we look for the measure of performance of country of establishment 2 at S2 is equals to 4. So S2 is equals to S2 is equals to 4. Now measure of performance of that is 90, where it occurs is at x2 after it is equals to 3 or 4. So x2 can either be 3 or 4. Okay, if s2 is 3, for example, that means whatever is left for country 3 is either 4 minus 3 is either 1 or 0. 4. Okay, remember what we did that time. Now you remove, there are 4 available. There are 4 available. You remove 0 for establishment 1. That means there are still 4 available for country 2, for establishment 2. Now establishment 2 may need 3. It can operate maximally either at 3 or 4. So at 3 it removes 3, it remains 1, but at 4 it removes 4, it remains 0. So that means for s1 we need either 1 or 0. So we go back to our table for the third country. That was my mistake. For the third country, at 0 x3 is 0. At 1 x3 is 1. Okay, so we come back here, and then hence f asterisk 1 4 is 90 with allocations. Now there's a mistake. Personally, I feel there's a mistake here. This is supposed to be 1. This is supposed to be 1. Okay, for country 3, or this of engineers to the 3, 90 additional person years. Alright, so I would advise that you watch this video a couple of times again if you don't understand. And if you have any questions, please don't hesitate to ask. Thank you very much for watching, and enjoy your day.